Question 8. ABC is a triangle where the angle ABC is 90. It's going to highlight just now because that's going to be useful later. We're told that P and Q are integers, that is whole numbers, and we're given 3 points on this triangle. We're told that A is P comma 10. We're told that B is minus 1 comma minus 5. We're told that C is 8 comma Q. And then it tells us that the gradient of AC is negative 6 over 7. And the end game here is to try and figure out what B and C are. Now I've highlighted all of the key bits of information here. What will definitely help you is to draw a picture involving this. Now the fact that A and C contain letters means you don't exactly know where you would draw them, but that's not a problem. As long as you have at least the visuals of a right angle triangle, it might help you in terms of knowing which topics are involved here. Now the only thing that we know for sure is what's in blue. That gradient of negative 6 over 7 is going to be a line that's sloping down the way, but not that steep. So that there, I'm going to make as AC. So A, I'm going to call this point here. C, I'm going to call this point here. And it doesn't really matter if that's accurate or not. Like, it's going to get the job done. So P comma 10, 8 comma Q are those. Now I have a right angle triangle at the other part. So what I'm going to draw here, I'm going to make sure that in my picture at least looks, nope, that's not a good start. It's going to at least look like a right angle. So something like this will hopefully come out. Okay, yeah, there we go. So we have a right angle here, and that's point B, which is minus 1 comma minus 5. So that's a diagram that shows all of the information that we have. If I just add the fact that this gradient is negative 6 over 7 here. And you have to ask yourself with these tricky questions, what topics are possible? So I'll tell you one topic that's definitely possible. Gradient of a straight line. They wouldn't have given you this if you weren't going to need it. So the gradient of a straight line is obviously relevant. The fact that they tell you that we have a 90-degree angle at B is also important, which gives us two options here, one of them being much nicer than the other. We have the knowledge of gradients that are perpendicular to one another. These gradients here, if you multiply those gradients together, you're going to get minus 1. So if you have, two gradients that are perpendicular to each other, and you multiply them, you're going to get minus 1 if 1 and 2 are perpendicular. That's the method I'm going to show in a minute, but there's also one more that's pretty nasty, but will still work in conjunction with the stuff to do with the gradient of AC. And that is if you do Pythagoras. If you use the distance formula to figure out the length of that line in terms of P's and numbers, you're going to use the distance formula to figure out the length of that line in terms of Q's and numbers. And then you're going to figure out the distance of this line in terms of P's and Q's and numbers. You can then substitute into Pythagoras in order to create an equation that way. But it's the most work. I will end this example by showing the first line of that, and then hopefully that will reveal itself as to why I choose not to use that. You basically need to do 2 out of the 3 things. So the gradient here, negative 6 over 7, that's what I'm going to start with. I'm going to quote here the gradient of our straight line using coordinates because we're going to be using this a lot. And basically our gradient of AC, which we know is negative 6 over 7, is going to equal y2 minus y1 over x2 minus x1 involving these coordinates. So I'm going to use Q as my y2, 10 as my y1, 8 as my x2, and P as my y1. It wouldn't have mattered if you set these up the other way around, 10 minus Q and P minus 8. It won't make a difference. Either way, you'll still get the same result as long as you do everything else correctly. For simplifying or getting this at least a little bit more friendly, I'm going to multiply both sides by 7. And at the same time, I'm going to multiply both sides by 8 minus P. That's going to get rid of both of these fractions. And then that will end up giving us a minus 6 bracket 8 minus P equals a 7 bracket Q minus 10. And I'm just going to break that out and rearrange it to look a little bit nicer. Minus 6 times 8 for minus 48. Minus 6 times P for a positive 6P. 7 times Q and 7 times negative 10 gives us the following. And then I'm just going to rewrite this as 6p, take away 7q, so I want all the letters on the left-hand side. And then if I add 48 to both sides, that will give me a minus 22 on the right. That there is the sort of dead end we're at right now. We don't know what p is, we don't know what q is, we need to figure out both. And hopefully, with enough practice and leading up to your exam, you'll realize that when you get an equation like this, 2 letters in one, you're going to be doing simultaneous equations at some point, most likely, and this is an example of that. So our first equation we have done. We now need to use, like I said, either information to do with these gradients being perpendicular or Pythagoras, but we're definitely going to do what's in green there because it's much nicer. It does, however, involve more of this, so we just need to be careful how we set this up. So we are going to be multiplying 2 fractions together, and our answer is going to be minus 1 because that's the condition that we know if 2 lines are perpendicular, their gradients multiplied to make 1. So for the first line, this one here, I'm going to do minus 5 take away 10 on the top. So minus 5, it's a bit small. Minus 5 take away 10 for the y's, and then a minus 1 minus p for the x's is the gradient of AB. The gradient of AC here, I'm going to have a q minus minus 5, and I'm going to have an 8 minus minus 1. I'm going to tidy that up a bit before making it look like that. So we have a minus 15 over minus 1 minus p times q plus 5 because of the double negative. And the double negative here will make the bottom a 9 equals minus 1. I can now multiply both sides by that red thing and multiply both sides by that blue thing in order to get rid of the fractions. So what I will have if I do that is a minus 15 bracket q plus 5. And on the other side we're going to have a minus 1 times by a minus 1 minus p times by a 9. Now I'm going to break out those brackets. First thing I'm going to do on the right hand side here is I'm going to multiply that minus 1 and that 9 together first before breaking out the red bracket. You'll just be more likely to not make a mistake if you do it that way. The left hand side will give us a minus 15 times q and a minus 15 times 5. On the right hand side, well actually I can rewrite this, there's nothing left to do on the left hand side right now. On the right hand side, if I break that out, I'm going to end up with a positive 9 and then a positive 9p when I multiply that out. What I want to do now is I want to get the p's and q's on the same side. The fact that there's a positive 9p here and a negative q term there means that I actually want to have the letters on the right here. So I'm going to have a 9p plus a 15q on the right after I add this to both sides. And I'm going to take away 9 from both sides so that I end up with a number on the left, giving me the following. Rewriting that underneath the equation over here, not an 8, 9p plus 15q equals negative 84, gives me my 2 simultaneous equations, or my 2 equations that I'm about to solve simultaneously, like so. So simultaneous equations, I want to make the p's the same number because they're the ones that are most similar. 6 and 9 both go into 18, so if I can rewrite both of these as 18 p's, that will allow us to then take them away to eliminate. In order to make that happen, there's a lot of colors going on here, but I'm going to have to multiply that top equation by 3 to turn that 6 into an 18, and multiply that bottom equation by 2 to turn that 9 into an 18. Minus 7q times 3, minus 21q, minus 22 times 3, minus 66. And on the bottom we're going to have a plus 30q, and we're going to have a minus 168. When we take these away from each other, doesn't technically matter which order you do it in. I'm just going to do top take away bottom because that's the way they're set up here. I have a minus 21, minus 30, that's going to give me a minus 51q. And on the right hand side I have a minus 66, take away 168, which is going to give me a minus 234. No, it's not. No, it's not, because it's a minus minus. Take away, you're going to end up adding. It's not minus 234. It's going to be minus 66 plus 168, which is going to give me 102. There we go. After that, we get q on its own by dividing both sides by minus 51. and that will give us q is minus 2 as one of our answers. And then p, I can sub that back into either equation. It doesn't matter which one. I'm going to pick the blue one because the numbers are smaller. So 6p minus 7q, q being minus 2, so I sub that in. It's minus 22. I then have minus 7p plus 14 is minus 22. Take away 14 from both sides. Divide both sides by 6. And that gives me my answer. P is minus 2 and q is minus 6. Just to highlight how nasty using Pythagoras would have been here, if you were going to set up the distance formula, which as a reminder looks like this, then you're going to have to do this for every single line here. You're going to have to use this formula and substitute in all of the p and 10 and minus 1 and minus 5. You're going to have to do that once, not once, but twice, and then 3 times. Before then, you have something squared equals something squared plus something squared. So if you think about the fact that all of this, or at least this part, once you square rooted it, is going to go in there, it's pretty nasty, so I wouldn't recommend you using Pythagoras. All the information was given you there. The yellow and the green part in the question told you that you were going to be doing stuff to do with straight lines, especially once you draw it using straight lines, using your perpendicular gradients. Made a lot of sense with that. Done.